Today we're solving two-step equations, and in order to solve two-step equations, we need to keep in the back of our mind the order of operations established by past mathematicians. So whenever we're solving an expression, the first thing we want to tackle is anything that appears in a grouping symbol. So by grouping symbols, we're talking about parentheses, brackets, absolute value signs. Once we've done those, we move on to any exponential expressions, anything that is with an exponent, so any type of power. Thirdly, we do any multiplication or division that appears in our expression. If we've got multiple multiplication problems, maybe a multiply and a divide, we always go from left to right. That's how we establish which one goes first. So just like when you're reading your book, you start reading on the left side of the line and you read across all the way to the right. We do the same thing with our expressions. When we have two things that are kind of a tie, they're both at the same point in our order of operations, we decide who goes first by going from left to right. The last thing we do is perform any addition or subtraction using the same rule we did with multiplying and dividing. If we've got more than one, we go from left to right. Now, why is this important when solving equations? Well, when we're solving an equation, we're not actually trying to find our answer to the problem. We've already got that final solution. What we're trying to do is work backwards and find a missing piece in our equation, represented usually by a variable. So we're going to be working backwards in order to establish that missing piece. So we have to keep this in mind because we're going to be working with our order of operations going backwards. So actually addition and subtraction is what we're going to get rid of first, multiplying and dividing, exponential expressions, and then anything in grouping symbols. So let's see how this works by trying a couple example problems. So here we have as our first equation, negative 3x plus 5 equals 2. So we already know our final answer, it's 2. We're trying to find out that missing value x. So we want to get x by itself. This is called isolating our variable. So the first thing we're going to do is get rid of the plus 5. So we had a multiply by negative 3 and a plus 5, but we're doing order of operations working backwards. So to get rid of that plus 5, I'm going to subtract 5 from each side because adding 5 and subtracting 5 will cancel each other out. So on this side of the equation, I'm left with just negative 3x. Over here, 2 minus 5 gives me negative 3. So now to get x by itself, I'm going to divide both sides by negative 3 because dividing is the opposite of multiplying by negative 3. These will cancel out, and I'm left with x. And over here, negative 3 divided by negative 3 gives me an answer of 1. Now, before I know that answer is correct, I'm always going to check it. And the way I'm going to check is by plugging that solution of 1 back into my original equation in place of the x. So I'm hoping for this answer of 2 here. So negative 3 times 1 is negative 3, plus 5 does give me 2, the answer I want, so it checks out. Let's try one together. So here I have negative 5 times c minus 9 equals negative 24. So I'm trying to isolate my variable. I'm trying to get c by itself. The first thing I'm going to get rid of is this subtract 9, and I'll do that by adding 9 to each side. So here it cancels out, and I'm left with negative 5c, and this equals negative 15, because negative 24 plus 9 gives me negative 15. Now to get rid of this times negative 5, I'm going to divide each side by negative 5. Here it cancels out, and I get c equals positive 3. So this appears to be my solution for my variable. But before I move on, I'm going to check this solution and make sure that it actually works. So in order to do my check, I'm going to plug 3 in place of my c. So negative 5 times 3 minus 9, hoping for an answer of negative 24. This is the answer I'm hoping for. Negative 5 times 3 gives me negative 15 minus 9. I'm going to change this to negative 15 plus negative 9, which does in fact give me negative 24. So the answer I wanted checks out. All along, I was hoping for this answer of negative 24, and in the end, that's the answer I got. So 3 is my solution for C. Let's try another one. We've got negative z over 3 plus 5 equals 9. So in this one, I'm going to get rid of my 5 first by subtracting 5 from each side. So this here will cancel out. And I'm left with negative z over 3 equals 4. But I'm going to put my negative with my number down here rather than stick it with the variable. So I'm going to put z divided by negative 3 equals 4. And to get rid of this divide by negative 3, I'm going to multiply each side by negative 3. So I get z equals negative 12. Now I'm going to check that by plugging it back in for z. So I had negative z, I'm putting in negative 12 for z, divided by 3 plus 5, hoping for an answer of 9. Well, negative 12 divided by 3 gives me negative 4. And negative 4, or opposite of negative 4, gives me 4, plus 5 does in fact give me 9. So it works. Let's try one together. So I'm solving for x here. So the first thing I'm going to do is add a half here to both sides. I'm going to get rid of this subtract a half. Cancels out and I just have left with x divided by 8 equals, and negative 7 halves plus a half gives me negative 6 halves, which is the same as negative 3. Now to get rid of this divide by 8, I'm going to multiply both sides by 8. Cancels out here and I get x equals negative 24. So let's always check and make sure that our solution actually works before moving on. So I'm going to plug in negative 24 in place of x. And I'm hoping for an answer of negative 7 over 2. So in this case, I'm going to get a common denominator. And I'm going to change this at the same time to add the opposite. So 1/2 would be 4/8, or since I did add the opposite, negative 4/8. And negative 24 and negative 4 gives me negative 28/8. And another way of writing negative 28/8 is to reduce it, and I get negative 14/4 when I cut it in half. And if I cut it in half again, I get negative 7 over 2, and great, that's the answer I was looking for. So it checks out. Sometimes we can combine like terms before we solve, and that's one of our steps in our two-step equations. So here I have 3y minus 8y equals 25. Well, the first thing I'm going to do after changing this to add the opposite is actually combine those y's. 3 is y and negative 8y together are negative 5y. That's my first step. Now to solve for y, I'm going to divide each side by negative 5. Cancels out here, and I get y equals negative 5. And I check it by plugging it back in for all of the y's. So I have 3 times negative 5 minus 8 times negative 5, hoping for an answer of 25. So 3 times negative 5 is negative 15. 8 times negative 5 is negative 40. If I change this to an addition problem, it's negative 15 plus 40, which does in fact give us 25. Let's try one more together. So this time we've got some grouping symbols. And remember, we're working backwards. So I'm actually going to get rid of this times 3 first by dividing by 3. Cancels out. So 9 divided by 3 gives me 3, and I'm left with just x minus 4, the problem that was inside my grouping symbol. Now I'm going to add 4 to each side to get rid of this minus 4, and I get x equals 7. So before moving on, let's check our answer. So for my check, I'm going to plug 7 in place of x. So 3 times 7 minus 4 equals, we're hoping, 9. So 7 minus 4 is 3, and 3 times 3 is 9, which is the answer we want, so it checks out.